Welcome, everyone. It was decided that as a department, we lack in having a operation skill set with technical rescues, and the best place to start with that is with rope rescue. So this is going to be the first installment of hopefully monthly installments of where the tech rescue lead for your shift is going to be getting together with you and conducting training on the disciplines of technical rescue, being rope or confined space, trench, or structural collapse. So our first lesson is going to be on rope rescue. It's pretty much a basic, rope rescue 101 class. We'll go through the presentation. I highly encourage when we get to any of these skills sections that you pause the slideshow or video and work on those skills. That's when we get to knot tying or setting up an anchor or something like that. At the end of the slideshow, a company officer needs to get a hold of the shift lead for their respective shift. For A shift, that would be Ogden Grinning. For B shift, that'd be Lieutenant Odway. And for C shift, that would be Lieutenant Marsala. Get a hold of them and coordinate a training to set up at Station 4 where you can put all of what you learned here today into practice. So a little bit about why we're here. Tactical rescues, as most of you know, they're a low frequency, high consequence incident. Our lack of training, skills, and knowledge can easily lead to something horribly going wrong. Some of the standards and objectives that we're going to go over include NFPA 1006, that's Technical Rescue Professional Qualifications, and NFPA 1670, that's the Operations and Training for Technical Rescue Incidents. NFPA 1670 is the one that's a lot more applicable to the operations level, meaning all of the line guys here at South Adams. When we're done with this, including the hands-on training that you complete with your shift lead, we should all be able to function as a member of a team during a technical rope rescue. That's, recognizing basic anchor systems, considering the safety of the systems, assembling mechanical advantage systems, supporting the technical attendant as he, prepares to go over the edge or as he is over the edge, and competently participating as a member of the belay team, the haul team, or the lowering team. The types of rope rescue that we encounter are either a low angle, steep angle, high angle, or what we call a high line. Low angle, typically that's going to be down an embankment, a vehicle drives off the highway, and you have to go down with a backboard or with a litter and save them. Bring them back up to the ambulance because the ambulance can't make it down the hill. Steep angle, there's a lot of gray area in that. I included this just because it is in the NFPA objectives. However, we typically just classify things as low angle or high angle. High angle is pretty much everything else that up to this point we've trained on as a department. That's going over the edge, rappelling, anything like that. And then high line, those are typically more applicable in a swift water scenario where you deploy a boat or when you have to traverse a long open span like some type of canyon or something like that. Now there's two types of rope that you'll see out there. The first one is going to be dynamic. That's what all of the rock climbers use. And the biggest reason for that is because if a rock climber was to fall, that dynamic stretch in the rope is going to help soften their fall and it doesn't put as much shock in their body. The other type of rope is static. This is the type of rope that we use here at South Adams. because you don't have to remove as much stretch from the rope. There is a little bit of stretch, but it's not as much as a dynamic rope. So we'll be able to essentially affect our rescues in a much quicker and safer time frame. The sizes of rope that you'll see, well, NFPA approves the use of ½ inch and 7/16. You could see that written as 13 millimeter or 11 millimeter, respectively. However, the North Area standard is ½ inch rope. That being said, if we happen to run a call with Arvada uses 7/16 or 11 millimeter rope. The main reason for that is just for their possibilities of having to pack rope and carry it a longer distance. Here, our highest incident threat, I suppose, would be some type of industrial accident where someone falls from scaffolding and gets stuck and we have to go rescue them. We're not having to hike 2 miles into a canyon to go rescue someone off of a cliff face. The next size of rope that you'll see is going to be the 7 millimeter cordage, and that's used for the Purcells. Purcells, what they are, they're essentially handy tools for the rescuers. There's multiple applications you can use them for. You can use them for ascending, for anchors, lots of different applications that the technicians, well, each one of the technicians should have a set of Purcells with them. And they know how to use those accordingly, and you, on the operations side, shouldn't really have to worry or use those too much. The 8 millimeter cordage, that's going to be all of our press cord. Most everyone knows that as the red rope and the green rope in the CMC bags. We have 1-inch tubular webbing. That is brake strength 4,000 pounds. And there is 1-inch flat webbing out there. Our closest department that uses flat webbing is going to be North Metro. All of the webbing here at South Adams is tubular webbing. We'll see later once we get into the anchor portion of this, where once you start adding webbing on webbing, it starts adding up, and that increase for the extra 2,000 pounds that you get with flat webbing, the necessity kind of dies out at that point in time. So that's why we use 1-inch tubular webbing here. Next, I love this phrase. Knots. Can't tie a knot, tie a lot. Well, I know almost everyone here says it, and they'll say it to all of the tech guys, and they think it's funny. However, professional organization, professional knots. That being said, when you tie a knot, make sure it's correct, first of all, and dress all of your knots. Make them look good. Some of the knots we're going to be going over: figure eight on a bite, figure eight follow through, figure eight bend, inline figure eight, double figure eight. We could just say the family of eights. Water knot, the alpine butterfly, double fisherman's knot, clove hitch, Munter's hitch, the mule knot, the trucker's hitch, and the prusik. Now, before we go on, like I said before, get a rope. As we go through this, there's going to be pictures, and I will do my best to tell you guys how to tie these knots. Unfortunately, I can't show you. But as you get to a knot, pause it, tie it a couple times, tie it behind your back, tie it with your eyes closed, and make sure that you have these knots down. Don't do it until you can get it right. Do it until you can't get it wrong. So the first one is figure eight. This is our most basic knot. That's why there's not a picture up here. All right. After you tie it, it should look like a figure eight. If it doesn't look like a figure eight, then it's wrong. This knot typically used as a stopper knot, in our bags, or just as a termination end for any of the rope. So on to the next one. Figure eight on a bite. again, one of the quintessential knots in firefighting. The thing about this knot has a 77% knot efficiency. As we're going through, you'll see that's actually pretty good knot efficiency. Now that's when it's pulled from the bite through the working end, or excuse me, the standing end. The standing end. When you pull the working end and the standing end of the rope, that's when your knot efficiency goes down to 56. Now, since this is tied on a bite, there's no need for a safety knot. I know that's been a little bit of controversy a few years ago. However, any of the knots that are tied on a bite don't need a safety knot. However, there are some, like our next one, that do. Our figure eight follow through. Again, just like the figure eight on a bite has a 77% knot efficiency, the only major difference with this one is that a safety knot is required, and that's because you start out with a loose figure eight and then you follow it through and then you tighten it down. Well, you're not going to be able to get it as tight as you would a figure eight on a bite. However, the necessity to go around something and then complete the knot could be there. So try that a couple times and we'll move on to the next one. The figure eight on a bend is a 51% knot efficiency, and the main reason for that is because you're opposing your ropes. Now, I just want to send this out there. Anytime you see the word bend, that means that you're joining two ropes together. Right? That's what that knot is meant for. So a figure eight bend is joining for two ropes of equal size together. So this is a lot like the figure eight follow through, however, you're following it in a different direction. Instead of making a bite, you're taking another working end of a rope and threading it through your knot. Our inline figure eight is our go-to knot for ice rescue operations. So this is the knot, if you guys remember, where you start out with the Z or with the S, then you flip it and make an E or a backward Z, then drop it, pull it around, and pull it through. I recommend that if you don't remember how to tie this, that you Google it. You will probably find a website called animatedknots.com. Highly recommend this site for any knots. They do a great job actually walking you through it, demonstrating each part of the process. The next knot is a double loop figure eight. This is always a really fun knot to memorize how to tie, because when you do it, especially with a rookie or something else like that, they can't ever figure out how you tied a figure eight on a bite with two loops at the end. So again, animated knots, if you aren't able to follow the picture here, go to animatedknots.com. They have it on there. Some people may be asking what's a practical application for this knot, and I agree, not every day, are you going to be loading two different things on the same knot. You're just not going to do that. However, once we get into anchor systems, when you have a shared anchor load, then this is a great knot to use for that. Next, we have the water knot. So everyone with a piece of webbing in their pocket should be very efficient with tying a water knot or a ring bend. Again, bend, it's joining two ends of a rope together, or in this case, webbing. So it's just an overhand knot tied loosely and then followed back through by the other end of this, by the other end of the webbing or by another piece of webbing, depending on what you're trying to do with the application. Our next knot is the Alpine Butterfly. Now what this is used for, it's used for a change of direction. It's got a 75% knot efficiency, so it's almost as good as the figure eight on a bite. and when you pull it end to end, just like figure eight on a bite, it's 57 versus 56, but 57% knot efficiency. So this works great for any, when you're hooking up a descent control device or any type of Stokes rigging or anything like that. This Alpine Butterfly is a great knot to tie. There's two different ways to tie it. One on the top is pretty much just twist it twice and loop it between itself, and then on the diagram on the bottom, you lay it over your palm 3 different times and move it from first to the end and first to the end again, and then pull it through. Again, just listening to me and watching these pictures probably isn't going to be enough for you to understand how to tie these, so please, please, please go to animatedknots.com. It's almost as if they're sponsoring this or something, but they're not. So they're just that good. So our next one is double fisherman's knot. So this is what we use to tie all of our prussiks with. Now all of our prussik is sewn loop prussik, so there aren't any knots in there. However, other departments still use tied prussik cord. So this is a good knot to know just in case you're with another department and they say, hey, quick, tie me a prussik. And then you know how to do the double fisherman. Our next one is the clove hitch. Again, a Fire 1 knot. Everyone should know how to tie this. This is what we would tie a ladder with during the Fire 1 JPRs. There's 2 different types of clove hitches, a open and a closed. Again, everyone should be able to do this one relatively easy. This next one is Munters hitch. This is a go-to hitch for most operations. If the tech guys can't decide whether or not they want to use an MPD, whether or not they want to use a Scarab or a Petzl ID, as a belay device or a descent control device, anything like that, typically they just say, all right, well, what about a Munters hitch? It's easy, it's quick, it's a half hitch and a half around a carabiner, and it works great. It's an awesome hitch for rappelling, for belaying, for descent control, anything like that. It really just works on friction around the rope and around the carabiner. The mule knot is how you tie off a Munters hitch. All that is, you run both sides or both of the ropes together, the standing end and the working end. Run them so that they're parallel. Tie a half hitch in one side and then wrap it underneath your standing end of the rope and loop it through and pull it tight. That way it's a quick, you just pull the tail end of the rope and it releases and you're back in business. So this is a trucker's hitch. We're going to be using this for any front ties or back ties on anchor systems. All it is a, you can use any type of knot that gives you a bite. Here in this diagram they use a figure eight on a bite. Our preferred knot would probably be like an inline figure eight or a Alpine Butterfly, but definitely the inline figure eight should be your first go-to knot for a trucker's hitch. Just make sure that your bite on that inline 8 is going the correct direction. But so after you tie the inline 8, you just wrap it around your anchor, take your rope, throw it through the bite, pull it back, and now what that does, that creates a mechanical advantage system, so you can tighten and tension up the system, and then you just tie a clove hitch around all of the other rope. So it holds it all in place, it's not going to slip. And then if you look at diagram number 5 down there at the bottom right hand corner, they use a carabiner instead of looping it through. That way it gives you a little bit quicker of a release if you need it. However, if you can't spare another carabiner, then it's perfectly acceptable to run it through the bight of the knot. So prusik cord, earlier we were talking about the double fisherman's knot. Double fisherman's knot is what you use to tie a prusik loop, and then to tie the prusik on the rope, you just essentially wrap it around the rope inside of itself. That probably isn't a very good descriptor if you don't know what I'm talking about. So again, go to animatedknots.com, look it up, do it. The prusik knot is a friction knot, and it's typically used to stop the progress or to slow the progress of a rope. Now, you see where it says 2 wraps and 3 wraps? That's just how many times you wrap it around the rope before tightening it down. We want to use 2 wraps for any single person or 300-pound loads, and anything larger than that, which would be a 2-person or 600-pound load, would be 3 wraps. The more wraps, the more friction. The more friction, the easier it is to stop. Alright, welcome back everyone from trying all those awesome knots and getting super good at those. What we're going to be going over now is a little bit of PPE. So whenever you're working on technical rescue incident, or when you're training technical rescue, anything like that, there's some special equipment requirements that we have. So helmet all times, whether or not you're working at grade, working at height. Thing is, you don't know who's above you. You never know when a nice 3-pound carabiner is going to drop out of the sky and fall on your head. So you always want to make sure you're wearing a helmet. Now, if you're working at height, you need to make sure you're wearing a red tech rescue helmet. There's no reason for us to have a heavy structure helmet up at height and accidentally fall off someone's head and then just be another risk factor for the guys on the ground. The next part is going to be gloves. I know everyone loves, their fancy bloodborne pathogen extrication gloves. However, if you use those, you're gonna tear up the rope. Right? Extrication gloves, they're meant to grip, and all of that extra grip will actually start to deteriorate the outer shell of the rope. So leather gloves or structure gloves. Preferably just use leather or rope gloves. All right. Utility gloves work great. Now harnesses. 3 different classes of harnesses. The first one is the Class 1 harness. Class 1 harnesses, these are going to be our ladder belts. It's simply just a single belt. Goes around a person's gut, goes around their waist, and has the possibility of connecting to something. Right? And there's rated webbing and stitching in the belt. Class 2 harness, it's going to be what you typically see a rock climber wear, where it's just the lower body or seat of the harness. Now, if you see another department having these, just keep in mind that these are okay for edge personnel. People not going over, people not affecting rescues, just used for edge protection only, for those people working close to the edge. Class 3 harnesses, these are what all of the technical rescue guys are going to be wearing as they go over the edge. These provide a full body harness, upper body and lower body, and these are the only harnesses that are supplied by South Adams. So you don't have to worry about trying to determine whether or not your harness is good enough or if it's the right harness. If you have one of our harnesses on, it's good. Now what do you do if all of the harnesses are gone and you're working next to the edge? All you do, you grab a long piece of webbing and make yourself a hasty harness. Take the middle of the harness, or middle of the webbing, excuse me, bring it up through your legs, pass the ends around your legs, through the loop that you passed up, and then go back around your waist and tie it in a knot. Pretty easy. Um, if you're working by an edge, remember you need to have a harness. These also work great for patients if they don't need a harness and they require a harness for any uh, litter evacs or anything like that. Now on to hardware. We've got a slew of hardware on the rescue. It's just one big old toolbox. Carabiners, uh, locking triangles, rigging rings or steel rings, anchor plates. Some people call those bear claws. We have pulleys. We have different types of pulleys. We have scarabs, 8 plates, 540s, ladder bar rack, Petzl IDs, and one thing that's not listed here is an MPD. And we'll go over that pretty extensively. Carabiners. Carabiners are super important. This is our #1 piece of hardware that we use. We need to understand the anatomy of the carabiner and how it works. So the long edge without the part that moves is called the spine. This is going to be our major axis for loading. We want to make sure that any rope, any accessories, any descent control devices, anything like that is loaded on one of the curves that connects to the spine, whether that's the lower or the upper. This is the part of the carabiner that's rated the highest for load-bearing capacity and will give us the best bang for our buck. There's a few different carabiners out there, locking versus non-locking. Anything that is going over an edge or that has a life safety rope in it has to be a locking carabiner. Now there's a couple different types of locking carabiners. The two that we have are going to be either a steel carabiner or an aluminum carabiner. The aluminum carabiners are silver and they have a blue gate on them, which in this picture is the silver piece. It's called the gate. And those aluminum carabiners, we want to try to reserve those only for confined space rescues and specifically for the attendant and any equipment that's going actually into the confined space. Just because we want to reduce that spark hazard. And some people may notice that in the CMC bags you have some gold carabiners and some black carabiners. The only difference on that is color. All right, that's just to help you guys out on the front lines, where you could say black is our load and gold is our anchor, or vice versa, or anything like that. It's just to make it easier on you guys. Another thing with carabiners that we need to pay attention to is if we're putting more than 2 things into the carabiner. So that could be a piece of webbing and a MPD, or a piece of rope and harness, or anything like that. We want to try to keep them down to 2. There are some times when we have to break that and put 3 things inside, whether or not that's 2 ropes and a steel ring, or I don't know, use your imagination. But when we do that, what we need to do is make sure that we're loading it parallel. So try to keep, if you have 2 ropes in there on one side and you have a harness connection on the other side, you want to make sure that those 2 ropes are tight against each other in the top part of the carabiner, right where that spine goes into the top of the frame. That way we prevent any tri-axial loading, because carabiners aren't designed to be loaded on 3 different axes. If we do need to load something on 3 different axes, like webbing or something like that for an anchor, what we want to use are locking triangles. So locking triangles, these are designed to be loaded 3 ways. I mean, each one of the corners of the triangle. So if we'll get into this when we get to anchors, but if you need to do a double loop anchor, locking triangles work great because it gives you 3 points of contact to use, and that's what they're meant for. Rigging rings, these are kind of cool because you don't have to worry about any axial loading because there is no axis on there. The only downfall with this is that there's no opening. So, if you're going to tie a knot, or if you want to put a figure eight in this, then it has to be a figure eight follow through. And then on top of that, you have to tie a safety knot, and there's just more work that goes into it. But we have all of these in the black heavy rescue organizers on the Rescue, and they're a viable option that we could use. So anchor plates, or bear paws, bear claws, puppy paws, depending on who you talk to, they've got a different name for it. This allows multiple lines from a single anchor. So you have your anchor point, then you have your webbing, then you have a carabiner connected to the webbing, then you take that carabiner, put it through the big hole on this anchor plate. From there, you can load 4 different rope systems or descent controls or anything like that onto that one anchor. Something to keep in mind when we get to belays is that you don't want to put a belay system and a descent system on the same line, and we'll talk about that later. Pulleys. There's 2 types of pulleys out there. When you guys get out to training up at Station 4, you'll see some of the non-prusik minding pulleys. Those are just used really just to help the rope move through. But all of the pulleys that we use on any rescues, anything like that, are typically going to be a prusik minding pulley. That's the pulley. It's the red pulley right there. That's kind of a bell shape. Now what that does is that prevents that prusik that we tied to, it prevents it from going up into the actual pulley. Because if it goes up into the bearing of the pulley, what will happen is it'll bind up and you'll get stuck and you'll just cause yourself a headache. These work great for change of directions. And one thing to keep in mind when trying to decide which type of pulley you want to use is that the pulley needs to be 4 times the diameter of the rope. So what size rope do we use? 1/2 inch. So the minimum pulley that we have are 2 inches, which is 4 times the diameter of the rope. And that all has to do with mechanical advantage of the pulley and the friction loss and everything like that. We're not going to get into that. Our next piece is going to be an 8 plate. 8 plates, if you see them, they're for rappelling only. Once upon a time, they had an application for belay systems. However, with the equipment that we have here, there are many, many more advantageous and safer systems that we can use. The problem with 8 plates with any descent control or anything like that is that they're only rated for a single load. So if you have a rescuer going down, he could use it to rappel, but you can't use it as a belay to bring someone back up, because if your main line fails and all of your weight is put on your belay, and that's your 8 plate, well, you just put 600 pounds on something that's only supposed to support 300 pounds. That's a problem. The CMC 540 Descender, I'll be 100% honest with you. I'm not a huge fan of this. However, just because I'm not a fan of it doesn't mean that there's not an application for it. Typically what these are used for is for confined space or any really slow descent scenarios. What the rope does, and you can kind of see it there on the actual apparatus, is it wraps around 540 degrees inside of a cam inside, and if that rope starts to speed up beyond, I think, 7 feet per second, then it'll lock. And then you have to reset it, and then go again, nice and slow, nice and slow. And if you pass that speed threshold, it'll lock up again. So they're a little cumbersome to use. However, if you get good at them, I've heard that they work great. Personally, it's not my favorite. Doesn't mean that we can't use them, and doesn't mean that we shouldn't be able to know how to use them. The Petzl IDs, we have 2 of these running around in the department. They work great as a descender, as a ascender, as a belay device. However, the issue with them is that they're more of a finesse tool than they are a strength tool. Like an 8-plate or a ladder rack or a scarab, anything like that, those are pretty much all strength. All right. When I say strength, they all work on friction, and you can manually, like if you tug on the rope, they'll stop. This, you pull that black handle, you find the sweet spot in the apparatus, and you descend or ascend, or excuse me, you descend or belay in that sweet spot. And again, most of any of these, quote unquote, high tech apparatus, like the 540 or the Petzl ID or the MPD, which we'll get to here in a minute, all of those will have diagrams on the front to help you guys with loading the rope, because there's no way that every 6 months when you break out a MPD, you're going to remember how to load it correctly every single time. So make sure you're following those diagrams correctly, and that will prevent any mishaps during any training or any live incident rescues. The ladder brake rack, we wanted to mainly talk about this for our next piece. These are a little antiquated, but they work great. They're a friction-based system. The more of those ladders, of the rungs in the ladder that you put the rope through, the more friction it's caused. More friction it's causing on the rope, which means higher load it'll hold, and the slower the rate of descent you'll have. So they're super simple to use as long as you load them right, and there aren't a whole lot of moving parts with them that can break, so they're pretty reliable. A lot like the ladder rack, we have scarabs. We have a scarab in each one of the heavy rescue organizers on the rescue, and they work on the same concept. You take a bite of the rope, feed it through the middle of the scarab, push that bar out of the way, and then fold the bar back down through the bite, and it works on friction. If you need to add more friction to the rope, you just wrap it around one of the horns on the scarab. It works great as a descender, as a belay device, anything like that. So one of my personal favorite descent control devices is going to be the MPD. The nice thing about this MPD, it's a multi-purpose device. That's right there in the name. You can use it as a raising apparatus, as a lowering apparatus. They're getting through to more and more of the North area departments, North Metro and Arvada. They were the first departments to have them. Adams County's just bought a few. We actually have 4 of them on the rescue, one in each one of the heavy rescue organizers for the rope systems. And they're a little cumbersome to set up, but after you set them up once, you understand how to set them up, you won't think it's that cumbersome. So just follow the diagram on the back of the plate, because if you notice so this is the front side of the apparatus with your T-bar and your parking brake. Then on the back side, that's where you have your diagram, and your back plate will swivel so you can load it through. And again, there are tons and tons of videos of this on YouTube. My recommendation is to go to YouTube, find a video that's actually posted by CMC Rescue. They're the developers of the MPD, and watch the instructional videos. They walk you through how to set it up, how to use the parking brakes, how to use the trigger handle, or excuse me, the T-bar handle, how to use the different friction points on there, and then how to set them up for mechanical advantages. This is probably the biggest time saver that we have. The Petzl ID can kind of sort of be used in the same aspect, just not as easily. So if you are sending a rescuer down with the MPD and then you have to raise them up all of a sudden, it's a quick and easy system to set up. All you do is a single pulley, one carabiner, and one prusik cord on that rope, and you have a quick 3-to-1. Another, if you incorporate a double pulley into that and another carabiner, then you got a 5-to-1. So depending on what kind of load you're hauling up, you can change it up really quickly and get the patient or victim to the medical attention that they need. So since these are fairly new, and if anyone is really versed in technical rescue specs, anything like that, here's all of your specs for you. They're rated for the 13 millimeter or half-inch rope, which is what we use. They only weigh 2 pounds and 8 ounces, so 2.5 pounds. And their strength, the pulley, if you notice back in the beginning of the presentation, breaking strength of the rope right around 9,800 pounds, the pulley is rated at that. Your descent control is a little bit more than half of that, and then your becket or the bottom hole for you is rated high up there as well. So now on to anchors. A few different anchors, simple anchors, back tie anchors. We have different anchor systems, webbing, anything like that. Natural anchors, structural anchors, vehicle anchors. We'll go all over these. Or simple anchors, it's just a single anchor point. When you're doing this, you want to make sure that they're bomb-proof. When you say bomb-proof, it's, if I was to run a Prius into it, would it move a whole lot? If not, then that's a bomb-proof anchor. When you're doing that, you need to consider the load that's being placed on the anchor. If I'm only hauling up a simple 300-pound load, then I could use a 4-inch tree. That's fine. However, if I have a 600-pound load, or if I incorporate a mechanical advantage system into that, so I could be hauling up to an 1,800-pound load with a 3-to-1 on a 600-pound load system. That anchor point needs to be able to support 1,800 pounds. When you're trying to decide which anchor point to use, let's say you got a grove of trees in front of you, you want to make sure that you choose that tree that is best in line with where your rescuer is going to be going over the edge. Because when that rescuer goes over the edge, if he loses his traction on the side of that face and falls, and your anchor point is far off to the right, he's going to pendulum all the way down past your anchor point to the other side and just start to swing. He's going to go on one of the rides for his life, and he's not probably going to be happy with the anchor team for their selection of anchor placement. Secondary anchors, these are going to be our back tie anchors, anything like that. Again, those need to be in line with the first anchor, just to prevent any of that pendulum swing or anything like that. So some simple anchor systems you can tie. This is the girth hitch. You really just tie a water knot and a piece of webbing, make a loop, tie it around your anchor point, and feed it through itself. And then just hook your carabiner on that bite that comes through, and you're good to go. Our single loop anchor is simply that. It's just a single loop of webbing tied around an anchor point with water knot in it. This gives you the straight strength of the tubular webbing or flat webbing, depending on what you have, minus or reduced by the knot efficiency. The wrap 2 pull 1 is wrapping your piece of webbing around an anchor point twice and then pulling one of those wraps out away from the anchor. One of the advantages of using any of the wrap pull methods is that your anchor won't slip on you because you have that friction around your anchor point from the piece of webbing that you don't pull. So that tightens down on your anchor and your anchor point shouldn't be moving. Then we have a double loop, which is going to be the example down here on the bottom of the graphic. All that is, that's two loops tied around a tree and both of them are pulled. The disadvantage of your double loop is now your webbing can slide up and down your anchor. So if you want to have the strength of two pieces of webbing, what you want to use is a wrap 3, pull 2, ideally. So again, just wrap it around your anchor point 3 different times, pull 2 of them. One thing you want to make sure is that that knot is on the piece of webbing that stays on your anchor point. So the basket loop, this is going to be a great time to use that locking triangle because you have one round piece of webbing wrapped around your anchor point, and then you have the 2 bites that are wrapped around attached through that triangle, and then you can attach another carabiner or rope or webbing, anything like that, to that third point on that triangle. So the tensionless hitch, it takes a little bit of practice to set up, and until you tension it, it will slide up and down your anchor. But once you do tension it, it's great because your knot efficiency is 100%. So you're keeping all of your strength in your rope. You're not losing anything. All you do is wrap it from the top down and then take it and secure it on the rope. You know, whether or not that's with a bowline or with a figure 8 on a bite and a carabiner, anything like that. Now, what do you do if your anchor, if you're a little skeptical about it? What you want to do is find a back tie anchor. So you have your primary anchor, which is this smaller tree on the front. Then you have your back tie anchor, which is the more substantial tree in the back. In between that is that trucker's hitch we were talking about. So you start out, tie your anchor on the front, and then you want to intertwine the webbing from your front anchor and the one that's going to be headed towards your back anchor. That way, if that front anchor or small tree was to come out of the ground, those pieces of webbing are going to catch each other. All right. So again, make sure to use this if you have any question whatsoever about that front anchor. You can use multiple points of anchors to have the whole anchor system support your load. When you do this, you could have one of the techs tie up radium release hitches on 4 or 3 of the anchors, however many you're using, and then tie those into a bear paw. Or you could tie into a load sharing, which we'll go over here in a minute, or a load distributing system. Now, one thing that you want to make sure of is that you don't exceed 90 degrees between the multiple anchor points. Once you do that, you're getting into too high of a load for those outside anchors, and they will tend to fail early during your operation. And once those fail, then all of your load is being placed on your other ones, so on and so forth, and it's just a domino effect, and you're left with no anchors and a rescuer down on the bottom with a couple broken legs. Like I said, load sharing and load distributing. Load sharing means that you're sharing the load between equally between 3 different anchor points. So that would be actually both of these cases here in this graphic. So both of these are load sharing. Now, load distributing is where the anchor point will essentially float within the system to find its own equilibrium. Those work really great, and the best knot to use for those is going to be that double loop figure 8. If you tie one of the loops small and one of the loops big, great tool to use. I highly recommend getting with one of the techs and practicing it. If you can do it before one of the techs can do it, awesome. Now we're going to start to get into belay systems and anchor systems still. One thing we want to talk about are the front tie anchors. Now, we went over the back tie anchors. A front tie anchor, it's kind of just the opposite. It's in the front. Now, the front tie anchor isn't meant to support much of a load at all. All it's going to do really is limit the stretch of the rope you're using for your anchor, and it allows for a floating focal point. Now, that can be laterally, that can be horizontally, or vertically, depending on what type of front tie system you do tie. Nice thing about this is it doesn't require, if you tie it high enough, it doesn't require anyone to be down on their knees, in the mud, in the snow, or anything like that. You can bring all of that equipment up out of the dirt and be operating it while you're standing. So belay systems, every single one of our operations needs to have a belay system. All right? It reduces the risk to the rescuers and the victims, and all it is, it's a second rope attached to a separate anchor. Now, when you're doing this, you want to try to make sure that the anchor that you use for your belay system is relatively close to the anchor that you use for your main line. Because if that main line was to fail and the entire load gets put on that belay system, again, you don't want to send your rescuer and your victims through a pendulum because your belay system was 10 feet off to the left. If you have two anchor points and you're trying to decide, which one do I want to use for my main line, which one do I want to use for my belay line, take your belay line and put it on your strongest anchor. Because if your main line fails, that's fine. I mean, it's not good, but we're going to survive. But we want that stronger anchor to be on our backup. Now, there's a couple different belay systems out there. There's Tandem Prusik, which, again, tandem, two of them in line, and it's Prusik. So they're cheap, they're reliable, they work. When they work the way that they're supposed to, what will happen? First you need to be using two different sizes of Prusiks. That's why they color coordinate them, red and green. Your red ones are going to be your short ones, and your green ones are going to be your long ones. What happens in a mainline failure with the Tandem Prusik belay is your short Prusik will capture all of the load. Then it'll break because you're applying more load on that Prusik than what it's rated for. And that's what this system is designed to do. So when it breaks, what happens is it takes some of that load and that reduces the amount of load being put on your longer or your green Prusik. So therefore your green Prusik will be able to hold the load and steady it for until you can figure out how to get the next person up or down, however you're doing it. So then back to mechanical belay systems. These are going to be any of our belay systems with a Scarab, with an MPD, with a Petzl ID, anything like that, a ladder brake bar. It just requires a specific device. Nice thing about these is that you're able to stop somebody's descent without locking up the system. Unlike with the Tandem Prusik, once that gets loaded, you stop their descent because that system is now locked. There's no way to unlock it. But the mechanical belay systems, you may be able to continue that descent with them. One thing to note when you are using a Tandem Prusik belay, this graphic here on the right, the operator, he's keeping some slack between the side. So the left side is the side with the rescuers on it, and the right side is the anchor point. He's keeping some slack between the rescuers and the anchor point, and that's really just for his own safety. Because if he was to keep that tension the entire time and just be pulling out, the little bit of rope he needs as that rescuer is going the down the face, then if it gets loaded, that rope could snap down on his foot, down on his hands, anything like that, and he could get injured. So just keep some slack in the system. That way, if it fails, you have a little bit more time to break your hands away and just let the system do what it's designed to do. I want to talk about a two tension or twin tension belay. Now, the North Area Tech Rescue Team, we have a rope rescue committee, and we've actually decided not to use this tension system, or the two or twin tension system, just because it's a relatively new system. While it is safe to use, the dissemination and the training that it would take to get the rest of the team who's been doing this for quite a while, the amount of training that would take would just be too cumbersome and unfortunately could result in some operator error with this system. But essentially what it does is it takes two ropes. If you guys look at the graphic on the left, the red rope and the blue rope, takes both of those ropes and it puts a identical tension on each one of those ropes. That way the load, or excuse me, half of the load is being carried by the blue one and half of the load is being carried by the red one. Therefore, your risk of failure is reduced in half, and you still have a second line there just as a backup. Now, lowering systems, these are all going to be, if you're not using an apparatus, you'd be using a Muntersitch. Otherwise, you'd be using a MPD, a Scarab, a ladder brake bar, Petzl ID, or if you're rappelling, you could be using a 8-plate. All these really are is a anchor point, carabiner, apparatus, rope through the apparatus. That's it. They just do take another team or sometimes just an individual to operate them, but once you get your hands on them, you'll find that most of them are pretty easy to use, and you'll have that understanding once you get your hands on them. Mechanical advantage systems. Whenever someone talks about a MA system or a mechanical advantage system, they're talking about hauling. So the average haul capacity per person is 50 pounds. Right? That's what a single person can pull safely on a rope. So a typical haul for a single rescuer is 300 pounds, or a single rescuer plus a victim is going to be 600 pounds. Something to keep in mind with mechanical advantage systems is going to be your stroke distance. Now what that is that's how far you can pull a piece of rope without having to reset your mechanical advantage system. Some of the common mechanical advantage systems we're just going to talk about here quickly is going to be just a 1-to-1, 2-to-1, 3-to-1, 3-to-1 Z-rig, and a 4-to-1. I know earlier when we were talking about the MPDs, we went over 5-to-1s. You could get all the way up to a 12-to-1 if you have a rope that's rope and anchor points and pulleys and everything that's going to work with that type of load being placed on them. Great. However, what we need to keep in mind is the total load that we're putting on the system. So this first mechanical advantage system is a 1-to-1. The picture represents the exact same amount of force that would be applied if you were just pulling the rope straight up the hill without any pulleys, without any mechanical advantage or anything like that. The only thing that pulley represents is a change of direction. So 2-to-1, real quick, take a look at where the figure 8 on a bite is in relation to the whole system. Up here, the figure 8 on a bite, or the termination of the rope, it's located up at the anchor point. Back on the one-to-one system, your termination point is located down at your load because you don't see it in the picture. So that being said, if you have a termination point that's at your anchor, your mechanical advantage system is always going to be even. So that's going to be your 2 to 1s, your 4 to 1s, your 6 to 1s, 8 to 1s, 10 to 1s, 12 to 1s, anything like that. If you have a termination point that's down at your load or to the patient, then it's going to be an odd mechanical advantage system, right? So that's your 1 to 1, your 3 to 1s, your 5 to 1s, anything like that. Now, with mechanical advantage systems, it's a perfect opportunity to do some math. So if you have a 300-pound load and you use a 2 to 1 system, really the only load that's being placed on your haulers, on your haul team, is going to be 150 pounds. So if you have a 150-pound load that they're pulling up and each person can haul 50 pounds, you only need 3 people to haul that one person up safely. If we beef up our mechanical advantage system into a 3 to 1 and we still have that same 300-pound load, then we only have 100 pounds that's being pulled. That reduces it down to 2 rescuers on the haul team. So when you're trying to decide which type of mechanical advantage system you are going to use, a few things you want to take into account are what's your load? Is it either a 300 or 600-pound load based on how many people you have? And how many people do you have to haul? Do you only have one person? Do you have 2, 3, 4? Just take the total amount of people you have to haul, multiply that by 50, and then take your load, either 300 or 600, and divide that by the total haul capabilities, and that'll show you what your minimum mechanical advantage system should be. So real quick, just a quick example. If you want, get out a nice pad of paper and a pen, take a 600-pound load. If you have a 600-pound load and we have only 2 people available for the haul team because limited staffing and stuff like that. So 2 people, they can haul together 50 pounds each or 100 pounds all together. That's 2 people. Now you have a 600-pound load. 600-pound load divided by 100-pound haul capability will leave you with a minimum mechanical advantage system needed would be a 6 to 1. Additionally, some more math, that 6 to 1 mechanical advantage system, because you're hauling a 600-pound load, the amount of force that you're putting on your anchor point is equal to the mechanical advantage system multiplied by your load. So your mechanical advantage system of a 6 to 1 multiplied by your load of 600, so you need an anchor point that's going to sustain 3,600 pounds of force. So now do you guys understand why we need bomb-proof anchors? This is an example of a 4 to 1. The example on the left, that's a fairly complex system for a 4 to 1. We probably wouldn't use that because if the termination was down at the patient, 3 to 1 or a 5 to 1 would work perfect for us. The more applicable application for a 4 to 1 is going to be our confined space. We have a pre-rigged 4 to 1 system in the confined space bag in the confined space compartment on the rescue. Pull it out, undo all of the webbing that's supposed to keep it all nice and neat, stretch it out a little bit, make sure that all of your ropes are aligned how you want them, hook it up to the tripod, and you're good to go. Now on to litter rigging. So part of your litter rigging, you have the Stokes basket, you could have a sked. Either one of those would count as a litter. But inside of that, we have patient packaging and attendant rigging. So the patient packaging, if you put them in a litter or a Stokes, anything like that, whatever you want to call it, they need to have a harness on them. All right. So go back to that hasty harness and just take some webbing, tie up a quick hasty harness, and now your patient has a harness that's going to keep them from slipping up and down that litter, and it also provides a tie-in point for them. When you do hands-on training with the tech rescue lead for your shift, they will go over how to secure that patient further inside of that litter for you. One thing to keep in mind with the new trucks coming in December, we should be having actual harnesses for our patients included in the Stokes kits. So with those, you shouldn't have to fashion a hasty harness or anything like that. You should just be able to use those new harnesses. But until then, take this time, work on the hasty harness here in this diagram, and get good at it. The next important part of litter rigging is going to be for the attendant. So you remember how I said that the hasty harness can serve as a point of contact or a point of connection for the victim? That's important because the victim and the rescuer both need to have 2 points of connection to the rope system. Those 2 points of connection are going to be your main line and your belay line. Additionally, if you're tasked with helping the attendant rig up their own system for an evacuation, make sure that they have some way to go below or above the victim. Based on the victim's needs, the attendant or rescuer will base their position appropriately. When you're doing the attendant rigging, one of the biggest things is to use 2 carabiners on the steel ring of the Stokes bridle. Those double carabiners need to have opposing gates, which means that the gates need to be on opposite sides. So that way, in case we, are going across any rocks or any metal bars or anything like that, and one of those screw links comes undone and that gate opens, we still have a carabiner protecting both our victim and our rescuer. On the rope systems themselves, you can either use any type of change of direction. That's an Alpine butterfly. You can use a figure 8 on a bite, inline figure 8, or a bowline. A few of the guys here at South Adams prefer to use the interlocking bowline system. There's nothing wrong with that. There's nothing wrong with using Alpine butterflies, nothing wrong with using figure 8s on a bite. You just need to make sure, and the technicians need to make sure to be able to recognize the difference between a safe system and an unsafe system. So, a couple quick notes on low angle rescues. These are probably going to be our most common rescues for what we're going to have to effect as any type of rescuer. As an operations person, there's a good chance that you're going to get put in the position of being an additional rescuer on this. We just don't have enough technicians to satisfy the needs for a low angle rescue. So if that's the case, quick note is that all of the weight of the patient should be on your harness. And this is going to give you the opportunity to use your hands for other things, whether or not that's patient care, whether or not that's carrying tools, whether or not that's for balance. So the mechanical advantage system, or the haul team up the top, they'll be setting up a mechanical advantage system, and that is going to essentially pull the weight of the victim and the partial weight of the rescuers. Since the rescuers aren't putting all of their weight on the system, they only contribute a partial amount of the weight. And then all you do as a rescue team, stand up and walk with the haul line up the hill. It's pretty simple. Like I said, anyone can do it, and the likelihood of you guys being on the rescue team during a low angle rescue is fairly high. So, thank you guys for sitting through this. Get out there, organize some training with your uh, shift leads, and while you're out there, make sure that everyone's acting as a safety. All right, don't go out there freelancing. Um, Listen to these guys; they know what they're talking about. If you have a question, make sure you ask. All right. If you see something unsafe, if you think something might be unsafe, bring it up. Bring it up to the shift lead and have them make that determination. All right, because we only have two eyes and there's many other parts that are going on. So if you have any questions, feel free to reach out to myself, Lieutenant Ottaway, or Lieutenant Marsala. Other than that, train hard and have fun. Thanks.